Today's topic is interoperability, okay? Interoperability in digital design, the first week. Precisely say, we're not going to deal with nothing totally new. What I mean is, we are going to deal with BIM as an extension of the Revit applications and the 3D graphics tools, 3D Max, and some interoperable issues in terms of geometry and building information modeling. So in the lab exercise hours, we're going to use Revit, 3D Max, Autodesk Vasari, and so on, okay? Even including bitmap image editor, Photoshop for today's lab exercise, okay? So we need to take a look at some about interoperability in our domain, digital design, as the course title literally means, okay? Digital design. So schedule, here we are. We ran out of the time, the half of this semester. So today and next after next week, we're gonna deal with interoperability issues before we are doing some video-based presentation issues for your final project, okay? And the midterm exam, final project, the date, some fixed. May 21st, midterm exam, fixed. Final project, June 11th, okay? You can use your design studio work, but even if your design studio is not reaching to the final at that date, that's okay. Your progress development will be presented in my class. And some mandatory participation at the end of May and early June, okay, for Revit, interior design, interior architecture, and so on, regarding digital design issues. So here I list up what to do today, lab exercises, and some post-processing using Photoshop demo. Okay, let's get started. Interoperability, okay? Interoperable issues in where? Of course, our domain, AEC/FM industry, right? Architecture, engineering, construction, and facility management. Kind of huge domain, okay? In entire general economic system. Usually, AEC/FM industry is one of the biggest industry parts, okay? Anyway, even in interior design or some planning, or some interior or building construction industry, whatever, we are in this domain. So interoperability issue in AEC/FM domain is our main topic. For what? So far, actually you already used interoperability, okay? You use SketchUp file in 3D Max. You import DWG CAD plans in 3D Max. That's one type of interoperability, okay? For design geometry. For design geometry, you may encounter a lot of problems. Some geometric shapes are missing in 3D Max when you import SketchUp file into 3D Max, or vice versa. And your CAD model, sometimes something missing in 3D Max or SketchUp, and so on. So that kind of issues are still in design geometry. But that's really tiny part of interoperability, okay? And or building information modeling, building information model, which contains geometry as well as a lot of associated information about building. So what are there? Let's take a look at the issue. Before doing that, we need to review the definition of design and design computing so that we can recognize why interoperability issue is critical. You know, something human brain area, something creative, okay? Something creative idea, something brand new, totally new ideas need, okay? Usually only can be done by human brain, okay? Creation area. And authoring means your idea could be visualized or generated in something concrete, something tangible, whatever, okay? you need to author your design, even in early conceptual level. And that design file should be developed, visualized, analyzed, and so on. Kind of very long-lasting and sometimes never-ending iteration, okay? Loop, infinite loop sometimes. In this process, some part of creation also can be done by computers, AI, machine learning, or something advanced. Smart CAD system supports creative area, such as generative design, parametric design. We're going to deal with this part next week, okay? Using Autodesk Vasari, generative design. Anyway, your design manually enhanced by using computational processing, okay? Entire process regarding centered around the design is design computing approach. That's what I'm teaching, okay? From intro to digital design, CAD and graphics, and now in digital design class, okay? And probably next year in theory course, design computing theory course. Anyway, human creativity area, and the goal is, of course, design, means computing technology. So by using computing technologies, we are doing some collaboration, okay? For one building, usually more than thousands of people are working for, okay? So how to collaborate, that's the main issue. 100 years ago, they generate a lot of papers, drawings, and share the papers, okay? To recognize design intent, construction method, and so on by using symbolized plans, okay? But now we are using computer files. So data exchange or file exchange is one important manner of collaboration. Another important issue is keep updated design, okay? Even if somebody made generated updates, it should be reflected to your central design file or design itself, whatever, okay? So while data exchange made, anyway, anyhow, building information should be keep updated. That's main focus in this collaboration, okay? So in terms of conventional architectural graphics, such as conventional legacy 2D CAD system or some CADD, CAAD, let me briefly show you again this process, okay? In your brain, in human brain, some of design idea, concept, totally new, or something blended, something challenging, something really creative one can be bringing, okay? They can be visualized so far only in that human, okay? Only for that person, only in his or her brain, okay? No one can see some specific things before this designer tells, describes, draws something else, okay? So anyway, that design is supposed to be one of the real world objects, but so far nothing is specific, nothing visible, okay? That is why we need to generate some computer files or some hand drawings and so on. So design presentation required to share this idea to someone. Actually, in your design studio, you need to share your idea with your instructor or other team members. Sometimes in your teammates, you have to share your idea to your teammates so that your design can be generate something specific. Anyway, this is digital design presentation. Actually, not mandatory digital. Sometimes totally handmade design presentation, okay? Something like this, usually. That is why we need to generate these kind of symbols. Plan, elevation, section, axonometric, isometric, diagram, pictures, slide, sketch file, 3D hand drawing sketch, animation, design panel, okay? Printed media, some printouts, okay? And so on. A lot of things for sharing your design idea from your brain. This is conventional way, okay? So the problem with this one is, you know that, very repetitive, time consuming, fighting each other, okay? Hurts. Geometric drawing, drafting, they always should be updated. If you change some design, you have to update elevation section, plans, and so on. All the time, very time consuming and tedious, okay? So by using computers, you can update the CAD model convenient and easier than hand drawing, but anyway, also time consuming. But actually, in terms of building information modeling and design computing, smart design computing manner, we can redraw that diagram in this way. Your idea is same in your brain. No one can see you, okay? No one can see you. But what if you generate a type of computational model which contains everything, okay? Actually, not everything at the early phase of generation. But at the end, this computational model is going to be very information rich. But at the first stage, that's going to be some roughly generated geometry and associated information. Anyway, if you have centralized, integrated computational model, for example, 3D Max file, Revit file, SketchUp model, whatever, okay? I'm not talking about which one is better, but anyway, that kind of computational model, especially in 3D geometry, is good candidate for computational model. Anyway, by using this computational model, now we can say it's going to be totally digital design presentation, okay? Because plans exported by this computational model. You experience the Revit 3D, you generate 3D model, and then your floor plans auto-generated, okay? Because that geometry is the subset of this computational model, okay? You don't need to redraw plan. They all integrated. So exported by that computational model. How about 3D rendering? 3D visualization, line drawings exported from that model, okay? Sketch, also different style, you can visualize this computational model. Also pictures, render scenes, and so on, all from this model. How about Excel file, which contains room schedule? They all generated from this computational model. You experienced that lab exercise, okay? Room schedule from Revit file, wall schedule, or other type of textual data from this model. How about animation? You can create animation using this model by additional task, some animation related things. Anything for design presentation, they can be derived from this computational model, okay? So this is one source and multi-use, okay? More information appended. For example, if this is SketchUp model, there is no way to assign material properties or some BIM-specific data. What if this is Revit file, BIM model? In that case, you can add amount of associated information, rich information, okay? Richer computational model. That means that rich information can be presented in several ways, okay? So anyway, one source, more multi-use, okay? Of course, another main keyword is shareable, okay? Shareable file. You don't need to share entire 100% of this file. If somebody needs design visualization part can be shared, okay? If constructor needs some construction-related quantity data or some precise plans, and then you can share that information only, okay? Anyway, this is shareable. And this is so-called building information modeling, okay? This is BIM's fundamental approach, one computational model. Actually, frankly, not one, multiple actually. But anyway, we can say one integrated computational model, that's the BIM. So how to share that computational model, okay? Okay, this is ArchiCAD example, Actually, we didn't use ArchiCAD, but similar to Revit or some other BIM authoring tool. In this ArchiCAD BIM application, or even if this is SketchUp or 3D Max, it doesn't matter. We can import and export a lot of files. You know that, right? 3ds file, 3D Max file, DWG, you know this, legacy CAD file, usually 2D or 3D, DXF, DWF, and SketchUp file, okay? Your favorite SketchUp file, Bentley system file, and so on, okay? Actually, these files and 3ds file, they are design geometry file, okay? Mostly contains geometry in 2D or 3D, usually 3D nowadays. And take a look at PDF, XML, text, Word file, Excel file. You are curious why they are here, but actually you can import text or Excel file and so on, or vice versa. You can export some PDF file from the model and so on, okay? For file sharing purpose or some other reasons. Anyway, they are design data or design information, okay? This PDF file includes some quantity data or some material data and so on. They are non-geometry usually, or fixed bitmap image geometry, okay? How about IFC? Actually, I mentioned IFC before. You can export IFC file from Revit, which contains BIM. In other words, which contains everything, okay? All about that building information. This file contains geometry in 3D and also contains amount of additional associated data, okay, in IFC file format. So which one is your interest so far? Probably this design geometry part, okay? But actually, this part is kind of major interest and issues nowadays in terms of interoperability, okay? But anyway, we are dealing with mostly this part, design geometry part, but it's okay. And also today's lab exercise mostly about this design geometry data exchange, file exchange, okay? How to share this file in terms of the interoperability issue? As I mentioned before, BIM includes design geometry as well as amount of associated data, associated information, so-called building information. That is why BIM literally means building information model or building information modeling, okay? Actually, in industry, there are really many different file formats. Something neutral, something proprietary. In other words, something commercial files, something is open to public, and so on. SketchUp file, KMG file, Google Earth file, or object U3D ATL file, mostly engineering specific 3D solid model file, usually for 3D printing, okay? Hopefully next month we can demonstrate 3D printers using such file formats, okay, in this room. Excel file, Word file, text file, PDF files, DWG, DXF, and so on. A lot of file formats you need to recognize, okay, in actual industry for design, file exchange, or file sharing issues. But actually, this logo is Building Smart IFC logo, Building Smart is the international organization which is in charge of managing IFC file format. There is only one file format, IFC. Okay, the reason that I show you this diagram or this one is this is conventional way, okay, legacy way. Too many files. What if there is 3D Max or Revit? How to exchange data between those two computer systems? Actually, I'm talking about human data exchange. But anyway, somebody will use this application. Another one may use Revit. In that case, we can talk human file exchange is equivalent to data exchange between this application and the other application, okay? In this process, in this shape, data exchange is really complicated and time-consuming and error-prone. Error-prone means something is always missing or something is wrong and so on. But what if you have this kind of bigger file format which contains everything and entire applications support this file format, IFC. This is open source, okay? Open public format. Anyone can see inside of this file. Anyone can generate this file, okay? Nothing proprietary, nothing commercial. This is totally free because international organization made this standard based upon some other industry standard, ISO based. Anyway, all others are kind of unnecessary if you use this file format, okay? And nowadays, almost every single BIM application supports IFC, import and export, okay? In that case, kind of 100% data exchange is possible, okay? That's the way to go in terms of interoperability. Anyway, this is BIM format. This is IFC, IFC XML, and zipped IFC file, something like that. So anyway, IFC, that's the file format. How to share this computational model in terms of design lifecycle or building lifecycle, okay? Planning, design, construction, operation. In terms of this lifecycle, sometimes several decades, hundreds of years, sometimes a couple of years. When we plan this design, this building, this interior, this area, whatever, anyway, top priority is visualization simply because no one can see that design idea, okay, in the planning stage. So probably most of you guys are focusing on this part, okay? Especially in school, your designs are usually design studio work, not for real world product. That is why we keep focusing on visualization. But actually there are a lot more. This is kind of preliminary part, stage, okay? Focusing on visualization. A little bit advanced thing is here, okay? Including planning and design area, some part of geospatial data, such as Google Map or some Google Earth data, as well as some detailed CAD plans or drawings, and design analysis, simulation things, and so on. Of course, containing almost everything for visualization. So this box shows you something you have to know, okay? Not only focusing on visualization, we need to keep eyes on something beyond visualization. But eventually, this is the way to go, okay? You have to know something about operation level information, data set, visualization, management, and so on. in this building life cycle, okay? In terms of this building life cycle, computational model can be visualized, can be import geospatial data, for example, Google Map data for your design site, and reused for design simulation, construction simulation, manufacturing simulation, and manufacturing shop drawings, very detailed drawings from your computational models, okay? And some management data and so on. At the top, as you see, IFC. This file format technically supports entire life cycle. Of course, there are some unresolved problems so far, but anyway, they're going to be resolved in near future, hopefully. So some CAD format visualization file, they are something preliminary, fundamental. Eventually, you have to keep your eyes on something beyond, okay? That's my point here, as always, okay? Let's quickly see some useful video files. Actually, I think you already watched some of those video files. But even if this is second, third time for watching this video, I believe now you can fully understand the main topic or the reason for this video, okay? Let's take a look at the first one. The first one is kind of Autodesk commercial video, but it explains some importance of integration. And the second one is OpenBIM. OpenBIM actually usually means IFC file format, but in this video, it will say some details about interoperability in very easy video content. And the last one is the second one, Autodesk BIM cloud-based interoperable BIM system. Actually, they are all related to the BIM, not simple CAD file exchange or SketchUp model importing into 3D Max. They are something primitive, but they are talking about something in near future, in actual industry, okay? So we need to take
comprehensive software solution that combines BIM and CAD tools to help you take advantage of Autodesk's portfolio of software for architecture. Design, visualize, simulate, document, and build better buildings with a set of tools that supports an end-to-end project workflow. Design better buildings. Built for building information modeling, Autodesk Revit helps you model design concepts and more accurately maintain your vision through documentation and construction. Any design change you make is updated throughout your project, keeping design and documentation coordinated and more reliable. Communicate your ideas more clearly and effectively to help win business and gain stakeholder approval. Autodesk Showcase provides an easy-to-use, real-time 3D presentation and rendering tool that helps transform designs into compelling imagery, movies, and live presentations. When you're ready to produce jaw-dropping visuals of your designs, Autodesk 3ds Max Design provides advanced modeling, rendering, and animation tools to help architects create cinematic quality visuals. Use integrated simulation tools to help inform design decisions earlier in the process. Energy analysis tools in Autodesk Revit provide architects with powerful, cloud-based analysis capabilities that enable you to quickly gain insight into the energy consumption and building life cycle costs of conceptual and detailed designs, helping you design more sustainable buildings. Create more consistent, higher quality construction documentation with powerful tools that provide native DWG support and automation tools that minimize repetitive tasks and speed time to completion. Improve control over project outcomes by sharing valuable design insight with all project stakeholders. Autodesk Navisworks enables the integration of multiple 3D models and data formats into a single model that architects, engineers, and contractors can analyze and review for better coordination, conflict resolution, and planning long before construction begins. The Autodesk Building Design Suite is a comprehensive software solution that combines BIM and CAD tools to help you design, visualize, simulate, document, and build better buildings.
Okay, kind of commercial video. But anyway, you watched something recognizable applications such as 3D Max for realistic visualization of even very detailed building interior, and Revit, okay? Revit is kind of centralized application in this kind of integration, okay? AEC integration, architecture, engineering, construction integration. Even FM can be integrated. Centralized computational model, usually Revit, okay? So you have learned Revit, a little bit about Revit. Rest of things is application of Revit or BIM. Okay, Open BIM. I think even if you watch this one again, I think at this time, in this time, you can.
A building project has many participants, including architects, engineers, consultants, constructors, and so on. They all have different roles, goals, agendas, and priorities. And firms usually run a number of projects in parallel. Combine that with the differences between building standards and conventions in different regions that require different solutions, and you'll understand why a single platform strategy is not the solution to the AEC collaboration. So if file compatibility is of little worth solving collaboration problems, let's see what the solution might be. Joe is an architect, Martha is an engineer, and Don is a constructor. They're working on the same building project and need to coordinate their work. Let's say Joe is designing a decent-sized building and needs to coordinate with Martha, the structural engineer. Joe sends his BIM model to Martha. And what does Martha get? The architectural BIM model that's full of architectural details. Such details are just noise for a structural engineer who needs only the load-bearing structures. So, she either cleans up Joe's model or starts the whole thing over from scratch. What we need here is workflow compatibility to ensure that the other party only gets elements relevant to her part of the job. Now that we've managed to get the appropriate part of Joe's model over to Martha, is she able to start her part yet? More often than not, the architectural logic of the BIM model doesn't 100% match the structural logic. For instance, columns in the architectural model may be modeled as walls, but the engineer really needs columns there for a structural analysis. What we need here is workflow compatibility to ensure that element interpretation is correct, regardless of the differences between the parties. Now we've solved these issues. Are Joe and Martha finally able to get to work with their respective models now? Sure, but as they progress, they continuously have to keep their work in sync. What we need here again is workflow compatibility to ensure that communication is bidirectional and that changes are handled in an intelligent way. You may have already noticed, but it becomes even more obvious once Don the contractor gets into the picture, that Joe and Martha were actually working on separate BIM models and only used the other party's model as a reference. The reason is that workflow compatibility requires that the real-world setup be mirrored, where parties carry full responsibility for their part of the project, hence, they also require full ownership of their own BIM data. As you witnessed in the previous 4 workflow issues, it's not file compatibility, but rather workflow compatibility that can make or break open collaboration between the various stakeholders of the AEC industry. With open collaboration, all participants of the AEC workflow enjoy unique benefits. Project members can choose to work with best-of-breed solutions in their respective field and location. Project members can decide about their software upgrades independently from their peers in different projects. Project coordination errors are greatly reduced due to workflow level compatibility in contrast to file compatibility. Accessibility of BIM data is provided throughout the entire life cycle of buildings, including construction and operation. To enjoy all these benefits, you're welcome to join the Open BIM community today.
Okay, the main term in this video is kind of intelligent workflow, okay? Actually, we already know what is intelligent way to collaborate each other in our design, architecture, engineering, construction domain. But it was not easy to resolve because too many people, too many different file formats, and two different point of interests, okay? How to integrate them, that's kind of long-lasting question. But one resolution, one solution is anyway building information modeling, okay, which contains geometry and entire information set for that building. The last video shows you something, some future environment of collaboration, interoperability issues using servers, cloud computing technology, okay? Also from Autodesk. Anyway, let's take a look at this video. Okay, let me stop this video here. This simply shows you rendering, okay? Usually you are suffering from render time, especially for animation making for this final project. Really slow in your desktop, even if you buy very expensive one, okay? But actually, we experienced homestyler.com or Revit network render or some backburner system render and so on. That kind of technologies are available nowadays. So anyway, it's up to your decision using conventional ways like this or try to do something cloud computing based render, rendered by other computers, and you can get some output results from such resting powers. Okay, in reality, you feel some advanced technologies are kind of outreached. It's not available to you guys, but actually, when you get your job in our industry, a couple of years from now, at that time, nowadays we are using LTE, okay, 4G network. How about 5G, 6G, 100, even 1,000 faster than now, okay? In that world, that kind of network-based cloud rendering, cloud computing, network access speed 1,000 times faster than now. And how about computers? Computer industry increased their powers amazingly, okay? And cheaper and cheaper. Your smartphone, tablets, powers are getting bigger and bigger, okay? So even if you are doing nothing, anyway, environment is continuously changed, updated, getting faster, getting better. Amount of technologies ready on your shelf. In that case, rest of ideas or remained things you have to do is how to take advantages of that given environment, given technologies. That's the question, okay? And BIM and something advanced features that I am talking about in the class, design computing, regarding design computing, is one of the solutions, okay? Several ways of interoperable 3D graphics. Let's quickly take a look, the series of slides, okay? First thing, today's lab exercise anyway. Anyway, in reality, back to reality, okay? Get back to reality from cloud and BIM and ready to get back to reality. Geometry-centered interoperability, okay? This is reality, okay? You import geometry file into 3D Max and you find out lots of things remained because they are just geometric shapes, okay? So you need to assign editable polygons, material, texture, light system, and so on to visualize your idea when you import this kind of geometry. What if you use FBX file from Revit? Revit is very easy tool to generate building model, okay? You experience that. If you import DWG file from Revit, it's nothing. It's just geometry, only with some few colors. But if you import FBX file like this, using manage link or whatever, in this case, simple edits of additional light system and so on, and then you can render like this kind of image quickly, okay? Or something like this. The same image, but which has its original material. Rest of the thing you need to do is enhancing the quality of this visualization because the visualization is not the best from the Revit. So you have to know how to enhance quality of this material, scenes, and so on. But actually, there are some reuse of geometry. You have to know, create geometry, modify geometry in 3D Max. They are one of the topics today's lab exercise. Importing or drawing this kind of footprint, base print lines, and to generate this kind of beams, some additional geometry, windows, walls, floor, and so on, okay? So this is one of the topic today's lab exercise, okay? And you can reuse given products geometry, okay? Sometimes you design this chair, design this robot, whatever, but you can easily import SketchUp 3D warehouse model or given 3D Max file, DWG file, whatever, such as these examples in today's lab exercise folder, okay? Resource furniture examples. We're going to use this one for today's lab exercise. And installing light, camera, adjusting material, and so on, so that you can render something like this, okay? You have to render something like this image today, and we're going to deal with something about post-processing to change, to update something like this image from this one, okay, by using Photoshop. That's one part of today's lab exercise. And the last lab exercise is going to be this one. This is design presentation purpose. This is original render scene, and this is final Photoshop edit. 10 minutes, okay? 10 minutes Photoshop. Designed by me, okay? So you have to submit something like this, today's lab exercise. Also, the last one is for next week, installation of Autodesk Bazari parametric modeling tool for next week's lab exercise. Okay, let's move to the lab exercises, okay?